Hello everybody, thank you for watching. This is our 9.8 video on the combined gas law. In this video, you'll learn the relationship between pressure, volume, and temperature using the combined gas law. Then, you'll use the gas law in order to solve calculations that involve pressure, volume, and temperature. Let's start talking about what is the combined gas law. The combined gas law takes into consideration Boyle's and Charles's law and basically combines them together. The formula for the combined gas law is P1 multiplied by V1 over T1 equals P2 multiplied by V2 divided by T2. And you can see inside the combined gas law, the top part where we're relating pressure and volume is talking about Boyle's law. And then when we're relating volume and temperature, that correlates with Charles's law. What we want to do is whenever we're using the combined gas law, we want to remember that our temperature always has to be in degrees Kelvin, and then we can do a little bit of algebra to solve for different variables. Once you take a look at the combined gas law, you can relate pressure, volume, and temperature together, and then you can solve for different variables that you need by combining Boyle's and Charles's law together. Let's take a look at some example problems. So the first thing you want to remember is the formula. P1 multiplied by V1 equals T1 over equals P2 multiplied by V2 equals T2. So our number ones represent our initial volume, pressure, and temperature, and that's going to equal our final pressure, volume, and temperature. If we take a look at our problem, it says if I initially have a gas at a pressure of 12 atm and a volume of 23 liters and a temperature of 200 Kelvin, and then I raise the pressure to 14 atm and increase the temperature to 300 Kelvin, what is the new volume of the gas? So what you want to do is read the problem and plug in values into our combined gas law formula. When we do that, we can see that our formula is going to be set up like this. Ultimately, what we're doing is we're solving for our final volume. So doing a little bit of algebra, we want to set V2 by itself, the variable. When we multiply and then we divide multiple variables, we can see that our V2 is going to equal 29.6 liters. Let's take a look at another problem. Here, it says a gas has a temperature of 14 degrees Celsius and a volume of 4.5 liters. If the temperature is raised to 29 degrees Celsius and the pressure did not change, what is the new volume of the gas? So I want to set up the problem like this. I want to first add 273 to our degrees Celsius in order to change it to Kelvin. And then in the problem, it says the pressure did not change. Because it didn't change, I can just hypothetically just add 1 as a variable into our pressure unit into the formula. I can see that the volume was initially 4.5 and we want to figure out what the final volume is going to be. By doing a little bit of algebra, you can figure out that our V2, which is our final volume, is going to equal 4.7 liters. Let's take a look at our last problem. If I have 21 liters of a gas held at a pressure of 78 atmosphere and the temperature of 900 Kelvin, what will the volume of the gas be if I decrease the pressure to 661.5 psi and also decrease the temperature to 750 Kelvin? The first thing I notice in this problem is we have units of atm and we have units of psi. We want to change this so we have similar units when we're plugging it into a formula. Also, I can see that we have our temperature already in Kelvin, so we don't need to do anything for that. And we need to figure out what we're solving for. It's asking us to solve for our volume again. So when I plug in values and change our units into atm, I'm going to get a formula that's set up like this. By doing a little bit of algebra, multiplying this way and multiplying that way and setting this variable by itself, I can see that I have a V2, which is our final volume, of 30.3 liters. And that concludes our video for today. Thank you for watching.